Hey everybody, Mr. Carr again. Today we're going to start off Unit 1 with Geometry Essentials here. When we go through this, our biggest thing for 1.1 is getting down our vocabulary that's going to be important for the rest of, not just this unit, but for the rest of the course. So to start, we're going to do a little bit of it's not much of an activity, but we're doing a little bit of just kind of go over our vocab here. So I have no dimension and am represented by a dot. This is a point in geometry. So when we look at this one, a point looks like this. Is it infinite, finite, or neither? It's neither. Okay. As far as notation goes, we always give it a name. So we do something like this and we give it a name like a letter. So we can say point A in this case. So I would read that as point A. I have one dimension. I extend in both directions without end. That is a line. So in geometry, a line does something like this, goes forever in both directions here. It's defined by 2 points. This is going to be infinite. When I have 2 points like that, so for example, if I call it A and B here for those 2 points, my notation looks like this. It is line AB. I draw the 2 lines AB, and then I do a little double-sided arrow above it. Now I could also do this as BA as well. So I can go AB or BA, it doesn't really matter. I have 2 dimensions and extend without end. So if I extend without end in one direction, this is going to be called a ray. So a ray has a starting point and it goes forever in another direction like this. This is also going to be infinite. Okay. So again, if I name it with 2 letters like AB, my notation is going to look similar to my line, except I have to do AB and I do a one-sided arrow. This point is going to start with what's called a terminal point. If it starts at point A, then I need to make sure my notation does the same thing. If I were to do it backwards and did BA, that actually is something different. It's not going to match up here. I consist of 2 endpoints and all the endpoints in between. This is a line segment. So if I have 2 endpoints, I call that AB, okay? This is going to be a finite. It has a beginning and an end to it. So if it has 2 endpoints like that, and we talk about, I don't think endpoints, it should cross that off. And all the points in between is actually a little bit better because it's all these points that are inside that line also are part of the line segment. But when we name it with those endpoints. So I can do AB with a line segment. Is it the same line? I could just reverse that and do BA. Either one works there. Okay. I have one endpoint and extend indefinitely in one direction. 1 second here. Very sorry about that. I totally got mixed up on these. And I got mixed up because of the 2 dimensions versus 1 dimension. Everything here for ray is actually down this one. So I apologize for that. Array is something that has one endpoint and extends indefinitely in one direction. That was more clear. I should have looked at that one a little bit more closer. I'll come back to the 2 dimensions one. So array has one endpoint. In this case, that point is A. It's still infinite. It's still notated this way, but ray is going to match up to that one. So my bad on that one. I have 2 dimensions and extend without end. This is a plane. A plane is any flat surface, like a desk. A desk would be a flat surface. A wall would be a flat surface that's 2 dimensionals. Okay. We usually kind of make it look like this. Okay. And what we do is when we name it, we'll just name it something like plane A. Like if I name it like with a with a letter like that. I put it there or I put it inside. Either way, it's close to it. This is also going to be infinite. Planes are going to extend forever in all directions, all 2-dimensional directions in that case. Okay. All right. Some other words we want to look at and some other concepts. Collinear. Collinear is when 3 or more points are on the same line. So if I have something like this, where I have a line like this, then I can just do A, B, C. A, B, C. Those are collinear. If I do something like this, ABC here, those are non-collinear. Okay, I cannot draw a line that connects all three. Not, at least I cannot draw a straight line that connects all three. Intersection is the point that two lines, rays, or segments share. So anytime I have something crossing each other and they share a point, that is an intersection. So for you try now, let's go ahead and do this together real quick. So if AB is represented by this function, 2x plus 5, that is going to be up here at a positive 5, and then up 2 to the right 1, up 2 to the right 1, down 2 left 1, down 2 left 1. There's my graph using my slope and y-intercept. That's AB, so it doesn't tell us exactly where A is on the y-axis. So A is right here, B is in quadrant 3. So that's going to be down here. Doesn't really matter where, I guess. CD is represented by 1/2 x plus 2. That's going to go up 2, then up 1 to the right 2, up 1 to the right 2, or down and to the left, down and to the left. Okay, so it does that. So that's CD. C is on the x-axis, so C is here. D is in quadrant 1. The lines intersect at point E, find point E. So I saw that they crossed right there. There's my intersection point. And that is crossing at the point -2, 1. Was another name for CD? Well, I could do a line DC if I wanted to. Identify two rays and two line segments. So I can do for line segments. Now, if I just want to focus on just this section of A to B like that, I can. That's a segment. So I can pull a segment out of a bigger line. So I can just do AB as a segment. I can do CD as a segment for the same idea. I can also consider rays if I start from like D and I go forever in one direction like that. So then in that case, I'll name it with DE if I want to there. So I'll go DE with one arrow there. In this case, if I were to switch the order, then it would be this ray. So I would do the opposite direction. So I could do that as well. I could do ED. There's lots of options here, but these are just a few examples. Before we end this, I want to go over a little bit more vocab. So now we're going to talk about stuff that we're going to talk about angles. I am made up of two different rays with the same endpoint. So if I draw, let me go to the picture first. So here's a ray here. Here's another ray here. This is what's called an angle. Okay. So an angle has two different rays with the same endpoint. Our picture is right here. When I name it, the name has two possibilities. I want either, let's put A, B, C on here. Two possibilities, but actually three names. I can name this angle ABC, angle CBA, or angle B. These are all three good names for this angle right here. This is the angle that we're referring to. The measure of this is finite. Okay, it has an exact measure. We can actually find that measure using some tools. So that is a finite measure. I am an angle measuring less than 90 degrees. So this is a very specific angle. It's called an acute angle. Okay, so a picture that looks like that is just any angle that is less than 90. So for example, if I just make it, I don't know, 30 degrees, we'll say. Okay. As far as the name goes, I'm going to skip that part here. We don't really need to do that. It's still the same thing as before, so it's not really different there. Measure is finite in this case. Whoops, let's do that. Finite. Okay, so then I move on to an angle measuring between 90 and 180. Okay, that is what's called an obtuse angle. And it looks something like this. So between 90 and 180 could just be 100 degrees then. Okay, again, names for that, it's going to either be 3 letters or 1 letter at the vertex like that. I should have probably brought that up. So the same endpoint of an angle has a special name. That name is called a vertex. So point B here is the vertex. So lots of times we can use a vertex for naming our angles. Our measure here is also going to be finite. I'm an angle measuring exactly 90 degrees. This is a right angle. Okay, picture looks like this. And we actually usually notate it with a little box in the corner. That's how we know it's a right angle. Okay. Name is the same, and that is finite as well. I'm an angle measuring exactly 180. So that is going to be, I went to right to the picture. That is what's called a straight angle. So it is basically a straight line, but it does have a measure like this. So in this case, this was exactly 90. This is exactly 180. Makes a straight line. That is also finite. Okay. And again, name is going to be 1 or 3 letters. Okay. And that is it for that. I'm going to leave these you try nows for you to do. Naming the angles, trying that out here. After that, give it a shot, like give that a shot on your own, but that is going to be it for our vocab for day 1. So that is it for 1.1. We'll come back and so do some more stuff with our angles later. All right. Take care, everyone.